Welcome to Study Loop.
Okay, folks, in this video we're going to be talking about this problem. A 5 μc particle, this is a unit of charge, it's microcoulombs. 5 microcoulomb particle moves through a region containing a uniform B field, -20 milliteslas, and a uniform E field, 300 volts per meters. At a certain instant, the velocity of the particle is this. And at that instant, and in unit vector notation, what is the net ENM force on the particle? Well, this is a relatively straightforward problem to solve. Basically, what we're going to be doing is we're going to be doing the Lorentz force, which is given by force. Lorentz force is going to be given by Q E plus V cross B. So when you have a particle that has a non-zero charge Q, and it's moving in a surrounding E field and a surrounding B field, then the amount of force acting on the particle is given by this formula. And that is what we're doing for this problem. So let's plug numbers in here. The reason I say this is a relatively straightforward problem to solve is because we're already given a lot of the information. We know Q, because Q is 5 mu coulombs, which is 5 times 10 to the negative 6 coulombs. And we know E, because E is in the y direction, it is 300 volts per meter. And we also know B. That means we know everything. We know B is, where is B? Okay, B is here, -20 mt. So, and it's in the x direction. So -20 times 10 to the -3, and then 0, 0, which is going to be -2 times 10 to the -2, 0, 0. Okay, and what about the velocity vector? Well, we also know the velocity vector, and that is 17 minus 11, and then 7, the whole thing times 10 to the 3, because this is kilometers, not meters. So we are given these three vectors. All we're looking for is the cross product of these two vectors plus this vector, and that is the force. So this is a very, very simple problem to solve. So let's start plugging in numbers. So Q, 5 times 10 to the -6. E is 0, 300, 0, plus 17 minus 11, and then 7 times, let me write that somewhere else, cross product with B, -2 times 10 to the -2, and then 0, and then 0, multiplied by 10 to the cubed. Okay, this is the answer. All you need to do is do the cross product, and then you add it to here, and then you multiply it by this number, and you're done. Let's set up the cross product without actually doing it. The cross product between V and B is I, J, K, and then Vx is 17 10 to the cubed minus 11 times 10 to the cubed, 7 times 10 to the cubed, and then B is -2 times 10 to the -2, 0, 0. This is the cross product. You're going to evaluate this determinant, and then after that you add it to the E field, and then you multiply it by this number. That's all we're doing for this problem. And when you do that, you're going to find that the answer, let me pull out the answer for you. Where is it? That answer is going to be a very simple expression. That's 0.8 millinewtons in the j hat direction, and then minus 1.1 millinewtons in the z hat direction. This is the force. The way you get this force is, like I said, you do this cross product, you add it to the E field, and then you multiply it by the Q. And you know, I think this problem is mainly computational. It's not a big deal. Okay. All right. So this is the answer. I will see you in the next video.